Other units of concentration. So we spent a lot of time talking about molarity, moles of solute per liter of solution, and that's by far the most common. However, it's not the only one. And this section talks about some of the other ones you probably will see along the way. Again, it's concentration we're talking about. Just little that or a lot, right? The concentration, moles per liter, is just one unit, one way of measuring it. As long as I'm getting a sense of how much solute per solvent, then that's going to be a good unit of concentration. All right, so let's just go through them one by one. Number one, mass percent. Instead of saying moles of solute per liters of solvent, like molarity, this one says, hey, how much mass of the solute, so grams maybe, instead of moles, grams this time, per mass of the whole solution. So you see it's still solute per solution, but instead of moles and liters, here it's mass and mass, so maybe grams and grams or kilograms and kilograms. As long as they're the same, we're okay. Now it's expressed as a percent, so once you get the ratio, then you multiply by 100 to get the percent. All right, so example 322, let's take a look at that as a way of learning this. It says a 5-gram sample of spinal fluid contains 3.75 milligrams of glucose. What is the percent mass of glucose in the spinal fluid? All right, let's see. I've got, oops, it jumped on me again, sorry. I've got 5 grams of spinal fluid. That's the whole solution. That's grams. Hey, that's like the bottom of this here, right? Mass of the solution. And then I've got 3.75 milligrams of glucose. All right, that's the mass of the solute. Now the only trouble is this one's in grams, this one's in milligrams. You got to use the same unit out here. And so this is the same as 0.00375 grams. All right? Grams of solute, glucose on the top, grams of solution, 5.0 on the bottom. Do that division and multiply by 100 to convert to a percent, 0.075%. All right, so not very much, right? Very little bit of glucose in the spinal fluid. Pretty simple. Again, it's just solute per solution, but we're using different units. Okay. Anyway, and we're expressing it as a percent. Now, because we're expressing it as a percent, if they actually give you the concentration in weight by weight or mass by mass percent, you need to be able to interpret that in order to use it in a problem. Now actually we were doing the same thing above. If I scroll back up here and just show you, when they gave us something like, oh actually that was in my scrap over here, when they gave us a concentration such as, here, 0.375 molar capital M, we interpreted that to mean, oh, I know what capital M is. It's moles of solute per liter of solution. So I didn't just leave it as 0.375 capital M, molarity. I did the interpretation of what it really meant. And we're going to do the same thing here. Okay? If they give us, I gotta find my spot. Here we go. Let's say, for example, they give us a 7% mass by mass percent, that is, of sodium chloride solution. I'm not going to just leave it like that. I'm going to interpret it. I know, hey, that means I've got a percent, that means per 100. That means I've got 7 grams of sodium chloride per 100 grams of the whole solution. Again, percent means per 100. So 7 grams, 7% solution means 7 grams of the solute per 100 grams of the solution. That's really important to always interpret it. If they give you the concentration, if it's molarity, interpret it as moles per liter. Right? If it's percent mass by mass, then interpret that again as that example here. Okay. Let's look at 323 to see how that might actually work. Here it says concentrated hydrochloric acid is an aqueous solution. So in other words, it's HCl, hydrochloric acid, HCl in an aqueous solution, so in water. It's a solution. You've got HCl dissolved in water. And they're telling me it's 37.2%. That's its concentration. You know what? If they don't give you exactly anything else, if they just say it's percent, then they're meaning mass by mass, or sometimes called weight by weight, that kind of idea. All right. They also told me that the density of that solution is 1.19 grams per milliliter. What mass of HCl is contained in a half a liter of this solution. All right, let's see. Here's the pertinent data again. I just rewrote it here in my notes. The solution is 37.2%. Hey, I know right away I'm going to have to interpret that. Density is 1.19 grams per milliliter. Oh, cool. I can use that to convert between grams of the solution and milliliters of the solution. Probably is going to be useful. And the total volume is 0.5 liters. They're going to ask me how many grams of the solute, how many grams of the HCl. Yeesh, where do I even start? This is just a big conversion problem. Let's first interpret. 37.2% means 37.2 grams of the solute, HCl, per 100 grams of the solution. Now that I've interpreted it, I can use that as a conversion between grams of the solution and grams of the HCl, which is great because what did they do? They gave me volume of the solution and they gave me the density, which converts from volume to grams of the solution. So it's a two-step conversion. Let me go through it. 500 milliliters. Why did I get that or use that? Well, they told me 0.5 liters, but if I'm going to use the density, which is in per milliliter, now we got to get them to do the same. So 0.5 liters is the same thing as 500 milliliters. And you should be able to do that conversion. Just move the decimal point 3 places. All right. Convert milliliters of that solution to grams of the solution. How do I do that? Well, I know the density. They told me that. Again, grams of the solution to milliliters of the solution. Grams to milliliters right there. Okay, so I put milliliters on the bottom so it cancels. Gram goes on the top, and it's 1.19 and 1. Great, my milliliters cancel, and now I'm at grams of the solution. They asked me for how many grams of the solute, grams of HCl. Well, there's my concentration. I know it's 37.2 grams of HCl in every 100 grams of the solution, and right now I've got grams of the solution. Great, I can use that as my conversion factor. On the bottom, grams of solution. On the top, grams of HCl. Again, that's from the concentration. And the numbers, find them right there. 37.2 grams of HCl. HCl is here, so 37.2 and 100 there. Grams of the solution cancel, leaving me with just grams of the solute. Grams of HCl, which is exactly what they asked me for. So I can put my equal sign, grams of HCl, and I pump all the numbers through. Turns out to be 221 grams of HCl. Let's just check that answer. Yeah, they got the same thing, 221 grams of HCl. All right, so it's just a big conversion problem. Okay. All right, that was the first unit, percent by mass. The second one that you might run into is a percent by volume. So instead of mass divided by mass, it's volume divided by volume. Again, it's always solute on the top, solution on the volume. So volume of the solute divided by the volume of the solution times 100. Right? Otherwise, it's identical. So instead of working in grams, we're working in volumes, maybe liters or milliliters. Example 3.24, let's take a look at that one. Rubbing alcohol is usually sold in a 70% volume aqueous solution, so 70% by volume. Notice, in the previous example, they just said 37% or something like that. This time they say percent volume. Right? If they don't tell you exactly what the percent is they're talking about, you can assume it's mass by mass. Otherwise, they're going to tell you, like in this case, percent by volume. So here I know, oh, they're talking about the volume of the solute divided by the volume of the solvent. Okay. It says the density of isopropyl is 0.785 grams per milliliter. Okay, cool. I can convert between grams and milliliters of that solution. How many grams of isopropyl are present in a 355 milliliter bottle? All right. I'm not going to do this one out. Let's just look at their solution. We're converting 355 milliliters of the solution. What do they do first of all? Here's the concentration. Remember they said 70% by volume. So 70 milliliters per 100 milliliters. Right? As always, per 100. Above, when we did the mass percent, it was per 100 grams. Now it's per 100, whatever volume you're going to use. In this case, they're using milliliters. Could have been liters, as long as it's consistent, same as top and bottom. Alright, so the milliliters of the solution cancel. That gives me milliliters of isopropyl alcohol. I can use the density to convert to grams. 195 grams of isopropyl alcohol are in that bottle. Alright, so you can see again, dimensional analysis, canceling out the units. That's what's key here. Third unit, weight by volume percent. This is called a mixed unit. This is perhaps the most unusual one, but what I hope to show you is that it's really no more difficult than any of the other ones. Yeah, I know all of these take a little while to get used to. You got to do a lot of problems before it finally starts to click, and that's the only way to get it to click is do lots of homework problems, okay? But a weight per volume percent is really no more difficult. What are they telling you here? Again, solute on the top, solvent or solution on the bottom, like always. Right? But this time, weight is on the top, volume is on the bottom. Right? So grams of solute per milliliter of solution. That's mass on top, or weight. That's volume on the bottom. And again, times 100 to convert it to a percent. All right. The one thing that you have to be careful of here is they always use grams on the top, milliliters on the bottom. Right. There are some variations on that, but we're not going to go there. If you always use grams on the top, not milligrams or kilograms, it's got to be grams. And the bottom, not liters, but milliliters. It's always got to be grams per milliliter. But if you use those units, you'll have the correct unit of concentration. All right, so for example, if they say a 0.9 weight by volume percent salt solution, right, I would interpret that to mean there's 0.9 grams of salt in 100 milliliters of solution. All right, 100's on the bottom, just like before. What is it? It's milliliters, so 100 milliliters is on the bottom. The top, 0.9 grams. Again, grams of solute needs to be on the top. The 0.9 came from, well, they told me it's 0.9%. Okay, so that's how I would interpret that. So weight by volume. You'll see a lot of times in biology or biochemistry, they'll use that unit. So it's important to get that down if you're going to be taking those classes as well. Again, it's really no more difficult than that. A lot of students get really tripped up on weight by volume percent. It's really not that bad. You do lots of problems, you'll get it. Our last two units, parts per million and parts per billion. These are kind of the same thing again and again. Parts per million. So per means divide. We're going to be divided by a million. ppm, parts per million. And so a ppm is defined as, again, they don't tell you otherwise, so it's going to be mass, grams, right? Grams of the solute divided by the grams of the solution times a million, or in other words, 10 to the 6th. Hey, remember when it was a mass percent? We did the same thing, but we times it by 100 because it's a percent, which was per 100. This time it's a per million, so we're going to multiply by a million. If you understood the mass percent, then you understand a ppm, parts per million. We're just dividing by that. Or going backwards, if they give you the concentration, say 4 parts per million of fluoride, then you should be able to take that and interpret it in order to do your problem. Don't just leave it as ppm. Say, hey, I know what that means. It means there's 4 grams per 1 million grams of the solution. Right? Instead of 100 on the bottom when we had a percent, because again, percent means 100, now we have a million on the bottom. Hey, and guess what? Parts per billion, ppb, same idea, but now we're talking about a billion, which is 10 to the 9th. So 7 parts per billion lead, that means there's 7 grams of lead and then a billion grams of the whole solution. Right? So they're just that simple. If you interpret them correctly, you should be able to do any problem out there.